Group 4 IB Biology Project by Sophie Chang, Katie Wang, and Raga Kalva. In the past couple years, we've been hearing a lot about something called the carbon footprint, but what is that? The total amount of greenhouse gases an individual or entity releases is known as its carbon footprint. Carbon dioxide is released by burning fossil fuels and results in a greenhouse gas. Electricity is a product of fossil fuel, and therefore, by reducing the amount of electricity we use, we reduce the amount of greenhouse gases emitted and our carbon footprint. This helps in the problem of global warming. Global warming refers to the continued rise of the average temperature of Earth's climate, and it has serious implications such as to the disruption of natural systems and the rise of ocean levels. By the continued burning of fossil fuels, we emit more and more carbon dioxide into the atmosphere, thus worsening the issue and polluting our air with more carbon dioxide and not allowing us to progress in helping the environment. The aim of our Group 4 project is to feasibly reduce our school's carbon footprint using biology. To do so, we plan to conserve energy through reducing the amount of time that bathroom lights are on without people in the bathrooms. Our school bathroom lights are always on, from the minute building services turn them on to when they turn them off, from 6:30 a.m. to 4:30 p.m. or even later till 10. But when you think about it, people are not always in the bathroom. We could install manual lights, but this includes a lot of human error, and students are not always aware when there are other people in the bathroom, leaving people in the dark. Our solution to this was to install motion sensors. By using motion sensors in the bathrooms, the lights would turn on and off only when there were people inside the bathroom. In a regular bathroom, the lights are on regardless of whether or not there are people in the bathroom. By using motion detecting lights and sensors, we reduce the waste by almost 200% and eliminate a lot of carbon emissions that would otherwise unnecessarily be used. Motion sensors come in different varieties in terms of light switches. Occupancy switches automatically turn the lights on when someone enters and turn them off when someone exits in order to avoid wasting lights and electricity with no one in the bathroom. By looking at many different models, our group decided that Lutron MS OPS2WH would be the best for our bathrooms because it fits wattage and would be the best in economizing cost and energy use. In Richard Montgomery, there are 14 total bathrooms. We collected data in essence, figuring out how much time during a school day the lights were on without anyone being in there. We estimated that the lights were on about 352 hours a week with 36 weeks of school, for a total of 23,672 hours with the bathroom lights on. We used an online statistic to get the cost model of 0.1099 kilowatts an hour from energy.gov. With our calculations using the model developed from the raw data, there are about 12,672 hours of lights being on in the bathroom during the school year without use, which accumulates to a whopping $560 wasted a year. To calculate an approximate amount of time and money saved, we took a 30-second shut-off time. The girls' bathroom is used 41.65% of the regular time, and the guys' is used 21.45% of the time that the lights are on with the regular lights. You multiply the percentages by 6,336 and by 0.1099 to get the cost. We result in $290 savings in girls and about $150 with boys, resulting in $440 saved a year. The normal price is about $560 per school year wasted, but with the auto lights, we're saving about $440 of that per year. You must add the original price of installation of the cost of the switches at about $436 a year. We get the equations as follows. The regular light equation would be y equals 560x. And the automatic light equation would be y equals $436 for 440x. We see on this graph that we'll be showing that they intersect at 3.633 years. Model, we see that the Lutron lights pay off very quickly and are a worthy investment for the school. Because our automated sensor uses passive infrared to detect motion, it can be blocked by stall doors and walls in the bathroom. So when we mount our automated sensor, it should be mounted on the ceiling above the stall so it can sense motion through the gaps above the stall doors. The panels that make up the ceiling of the bathroom are removable, so installing the automated sensor should be as simple as connecting it directly to the main wire that feeds electricity to the lights in the bathroom, thus allowing it to control when the lights turn on and off. Some weaknesses of research include that data was only accumulated on a half day, which may have something to do with students' bathroom tendencies. We also only observed second-floor bathrooms, which may differ from other floors. We were also unable to obtain a specific cost model for the school's energy costs, so we went with a general model that originated from energy.gov. A limitation that occurred in our research include that bathroom use varies from day to day, which means that a specific model cannot be determined for bathroom use on every single day. We led to a general model based off of our raw data accumulation of regular time spent in the bathroom. Lutron lights have a big payoff, in especially boys' bathrooms. If the sensor works well, we can eventually reduce the cooling off time from 30 seconds to something shorter. Since our school is very new, it is unlikely that would renovate or rebuild before 3.63 years, in which the time the cost of installing the lights would have paid itself off in a cost-effective and eco-friendly way to help the environment and reduce the school's carbon footprint and carbon emissions.